This is a Tech Math 3 pre-calculus class. We're going to do section 13.3 and 13.4 today. So in 13.3, we're talking about double and half angles of trig functions. And so we have some formulas we have to remember. Now all of these are on the in the back cover of your book, so that you don't have to memorize them, but you are going to have to use them. So the double sine formula is 2 cosine times sine theta, and the cosine function, double cosine function, is slightly different because we have multiple equations for it. So cosine squared minus sine squared, and or it could be written as 2 cosine squared minus 1, or it could be written as minus 2 sine squared minus 1. And this is a direct result of the equation that we have that says 1 is equal to cosine squared plus sine squared. If I go and substitute that back into the top equation, then it's easy to get the other guys out. Okay, the next guy we have to deal with is the double tangent formula. So if I have a double tangent angle, I have 2 tangent divided by 1 minus tangent squared. Maybe in the book someplace we'll be asked to prove that. These are all on pages 456, 457. And then we get to page 459 and we find we have a set of half formulas, half angle formulas. So the sine of theta over 2 plus or minus the square root of 1 minus cosine divided by 2, and the cosine of theta over 2 plus or minus square root of 1 plus cosine over 2, and the tangent of theta over 2, 1 minus cosine divided by sine. And all of these things are easily proven, and maybe there'll be homework problems on that and maybe not. Then we have a set of equations on page 461, 8 different ones that are that rearrange the addition and subtraction of angle formulas into double and half angles. They're not as useful as they could be. Alright, so we're going to start with problem number 2, and it wants us to simplify 20 sine squared x cosine squared x. Alright, so we're going to simplify that. And we see that if we had square root of 20 sine x, sine x cosine x times the square root of 20 sine x cosine x, then that would be the same as what we have on top. So that would be pretty cool. And then we could say, well, this is square root of 20 is 2 the square root of 5 sine x cosine x squared. And then we could say, well, 2 sine x cosine x, that's just 2 theta. So this is going to be the square root of 5 sine 2x, the quantity squared. And then we could say, well, that'd be a 5 sine squared 2x. And then that would have simplified it. I don't see that that's overly more simplified, but that's all right. Going to look at number 4. And we see we have the square root of 1 minus cosine 6 theta over 2. and we go back to the half angle formula, and we see that 1 minus cosine over 2, the square root of, is the sine of theta over 2. So we can just write this as the sine of 6 theta over 2, which ends up to be the sine of 3 theta. And then number 6, we have cosine 2x plus 2 sine squared x. We go back to this double cosine formulas and we find one that we like. And if we pick the one that's 1 minus 2 cosine, we could write this as 1 minus 2 sine squared x plus 2 sine squared x. And now that comes out to be 1, which is pretty simple. Looking at number 8, 10 cosine squared 44 minus 10 sine squared 44. We recognize this as the cosine of 2 theta is cosine theta minus sine theta. That's the formula we're going to use. And sine squared theta. And so the 10 comes out, and we're going to end up being 10, the cosine of 44. Not really. 44 times 2, which would be 88 degrees. And we could actually write that as a number if we wanted to, if I had my calculator out. 10 times cosine 88. So we could write that as 0.35 if we wanted to, 0.35. But I'm sure that there's nothing wrong with that particular answer either. Okay, we're going to move down to number 18. And we want to find the sine of 2 theta. Okay, so find sine 2 theta. Now we know that 2 theta is equal to 2 cosine theta sine theta. We know that. So that's something we know. And because we're on 18, we have the sine of theta is 3 over 5. And theta, in this case, is in the second quadrant. Okay, so we draw a picture here. And we have y is 3 and r is 5. And we know that if we have 3 and a hypotenuse of 5, that this is a 3, 4, 5 triangle. 3, 4, 5 triangle. 2 sides, 3 and 4, and the hypotenuse is 5. So that means that the cosine of theta is going to be the x component minus 4 divided by 5. And now we want 2 times 3 over 5 times minus 4 over 5. And we would get something over 25. And we have a minus sign, 12 times 24 over minus 24 over 25. And then we'd ask ourselves, if I double this angle, what quadrant am I in? And it would appear I'm going to be in the 4th quadrant. And is y going to be pretty negative compared to the other guy? And the answer is going to be yes. So that would be what the sine of twice the angle would be, minus 24 over 25. Okay, turning the page. Now we're going to have to show something. We'll look at number 24. And we're supposed to show that 2 tangent over sine 2x, tangent x over sine, is equal to 1 plus tangent squared x. All right, well, I guess we'll keep that side the same and say this is 2 sine x over cosine x divided by 2 cosine x sine x. And that's supposed to be what's on the other side. And then we say, well, if I get rid of my 2's because they go away, so that's not a problem. And I get rid of a sine, a cosine. No, I don't. I'm gonna go and multiply top and bottom by 1 over cosine sine. 1 over cosine sine. And I'm going to have 1 over cosine squared divided by 1. Okay, so 1 over cosine squared is supposed to equal 1 plus tangent squared x. It is, huh? Okay, so what are we going to do about that? Okay, so this is going to be 1 over 1 minus sine squared x is supposed to be 1 plus tangent squared x. If I multiply top and bottom, what's 1? Okay, so 1 is sine squared x plus cosine squared x divided by 1 minus sine squared x. Okay, and I see a clear path to where we're going in case you were wondering. Now what's 1? So I've got sine squared x cos plus, that's a plus sign, cosine squared x divided by sine squared x plus cosine squared x minus sine squared x. And then I've got sine squared x plus cosine squared x divided by cosine squared x, and that becomes 1 plus tangent squared x, which is what I'm looking for, so I'm done. And I probably should have gotten there sooner, but I got there, and that's all that matters. Okay, we're going to do number 34 next. Number 34. So I've got 2 cosine squared theta over 2 is supposed to be 1 plus secant theta divided by secant theta. Well, 1 plus secant divided by secant is just 1 over secant, which would be cosine theta plus 1. So that's all that I have over there. This is the squaring of the half function. Okay, so we're going to square the half function of the cosine. So we're going to go 2 times the square root of 1 plus cosine theta divided by 2, and we're going to square that. Well, isn't that convenient? The 2's go away, and we have cosine theta plus 1 is equal to cosine theta plus 1, and we are done. Okay, we're going to move on to section for 13.4, and so we're in 13.4. So let's say I want answers between 0 and 360, and I want them of something that looks like the sine of 4x is equal to 1/2. Okay, well that seems reasonable. Now the amplitude is 1, and the period of this function is 2 pi over 4, which is going to be pi over 2. So every 90 degrees this guy repeats. I write the function, I go up, I go down, I come back, I'm at pi over 2. I go up, I go down, I come back, I'm at pi. I go up, I go down, I come back, I'm at 3 pi over 2. I go up, I go down, I come back. I'm now at 2 pi, which is 360 degrees. Okay, so I want all the answers from 0 to 360 degrees of 1/2 when that function is equal to 1/2. So I would come up here to 1/2, and I would draw a line across, and I see I have 1, 2, 3, 4, 5, 6, 7, 8. 8 different answers. Alright, so now I got to go find all 8 of them. So what can x be? Well, if that's the sine of 30, then the sine of 30 is 1/2. So this first guy is going to be 30 divided by 4. 30 divided by 4. So what's 30 divided by 4? And that'd be 7.5. So the x's, the first x happens at 7.5 degrees. And then we go looking for the next x. Well, that's going to be 30 in the second quadrant would be 180 minus 30, which is 150. So this guy is going to be 150 divided by 4. So 150 divided by 4, 37.5 degrees. And then we go looking for the next guy. He's going to be 7.5 degrees after 90. Okay, so 7.5 degrees after 90, 97.5 degrees. He's going to be 37.5 degrees after 90, so he's going to be 127.5 degrees. Okay, next guy is going to be 7.5 degrees after 180, 187.5 degrees. The next guy is going to be 37.5 after 180, 117.5 degrees, 217.5 degrees. And the next guy is going to be 7.5 degrees after 270, 277.5, and then it's going to be 37.5 degrees after 270, 307.5. And then that way we get all of them, so we have all the answers. Now, without the graph, I wouldn't be able to do that, so I got to make a graph. I have to remember what happens in the first quadrant, that the sine of 1/2. Sine is something is 1/2, that something is 30, so I'd have to know that. And now I can go back and put in the answers to see if I'm right. So I'm going to go the sine. I'm going to take the sine of 4 times, and we'll try the 215. 217.5, close parentheses, and I get 1/2. Okay, so I checked that one. I find it to be true, so my reasoning for getting the answer is probably okay. If I have any doubt, I'd have to put each of those back in the equation to see if they worked. All right, now that's an interesting problem. Normally we don't have that many answers, So we're going to look at number 2. And we have the 2 sine of x plus the square root of 3 is equal to 0. So we have 2 sine x is equal to minus square root of 3, and then sine x is equal to minus square root of 3 over 2. Well, I recognize that if I had sines and I had 0, 30, 45, 60, 90, then the sine of 0 is 0, the sine of 30 is a half, this is the square root of 2 over 2, this is the square root of 3 over 2, this is the 1. So at minus the square root of 3 over 2, I'm at, in the first quadrant, reference angle is 60, but I'm negative, so the sine's going to be negative in the third and the fourth quadrant. So I'm looking for a third and a fourth quadrant answer whose reference angle is 60 degrees. Okay, so x in the second quadrant, 60 plus 180, 240. X in the third quadrant, 360 minus the reference angle for 300 degrees, and I'm all done. I only have 2 answers. I could have gone and do a graph like that and showed that I only had 2 answers as well, and I'm going and looking for them. All right, now I'm going to check my answer. What is the sine of 240? And I got minus 866, well, times 10 to the minus 3, so minus 0.866. What is the square root of 3 over 2? Square root of 3 divided by 2 is 0.866. So those are the same numbers, and I have the right answer there. Now moving on to number 10. I have 4 sine squared of 2x is equal to 3 over 4. No, it's not. Is equal to 3. I got the sine of sine squared of 2x is 3 over 4. I have the sine of 2x is the square root of 3 over 4 over 2. Square root of 3 over 2, and I'm plus and minus. Okay, I find that the period of this function is going to be 2 pi over 2, which is going to be pi. So my sine wave is going to go up, going to come back down, going to get back here, I'm at pi. I'm going to go up, I'm going to go down, I'm going to get back there, I'm at 2 pi, which is 360 degrees. I need an answer that's going to be plus the square root of 3 over 2, and also an answer that's minus the square root of 3 over 2. So that means I'm looking for 1, 2, 3, 4, 5, 6, 7, 8 different answers are associated with this problem. So that's the number of problems I'm looking for. I recognize the square root of 3 over 2 as having a reference angle of 60 degrees. I recognize that I have a 2x, so this first angle is going to happen at 30, because 2 times 30 is 60. That's going to give me that first answer. So my first answer is going to be at 30 degrees. So x is equal to 30 degrees. I'm going to have another answer, another answer, another answer. This answer is going to be 30 degrees past pi. So I'm going to have 1, 2, 3 more answers. But 30 degrees past pi is going to give me 210 degrees. So I've got that guy already. Okay, now I'm looking for the guy over here, and let's 60 degrees as a reference angle, and the second quadrant would be 120, and half of 120 would be 60. So that angle right there is going to be 60 degrees. Okay, so 30 would be an answer, 60 would be an answer. I'm going to be 30 degrees on the other side of 90, 120. I'm going to be 30 degrees before 180 degrees, so that'd be 150. I'm going to be 30 degrees before 270, which would be 240. And I'm going to be 30 degrees after 270, which would be 300, and then I'd be 30 degrees before 360, which would be 330. Okay, well, we'll go back and check our work, and we're going to put in we recognize square root of 3 over 3 is square root of 3 over 2 is 0.66. Okay, so whenever I put any of these numbers in, if I go sine of 2 times 330, I should get 0.66, and I do. And if I go sine of 2 times 300, I get the same thing. And if I go sine 2 times 120, I get the same thing. So all these answers are going to check, and we're done with number 10. Okay, we're going to move down to number 16. And we have cosine squared x minus 3 cosine x plus 1 is equal to 0. Okay, well, we recognize this as an equation in the form x squared minus 3x plus 1 is equal to 0. We ask ourselves, can I factor it? And the answer is no, but we can use the quadratic formula on it and say cosine x is going to equal minus 3 plus or minus the square root of minus 3 squared minus 4 times 1 times 1 divided by 2 times 1. And we get that cosine x is going to equal to 3 over 2 plus or minus, that's a 9 minus a 4 would be a 5, so it would be square root of 5. Now, we also recognize that the cosine function is something that goes to 1 and goes to minus 1, plus 1 minus 1. So this has given us an answer that's greater than 1. So the answer that's 3 over 2 plus the square root of 5 over 2 won't work, because cosine can't go above 1. So that means the only case we have to look at is when our cosine is equal to 3 over 2 minus the square root of 5 over 2. Okay, and we say, okay, well, that's fine. 3 divided by 2 minus the square root of 5 divided by 2 equals, and we come up with 0.381, and we say, well, x is going to be the arc cosine of 0.381, and we end up with arc cosine 67.5 degrees. 67.5 degrees. Okay, and then we go and say, well, the cosine function starts at 1, comes down, goes back up. So if we're at 67.5 degrees, we're going to have two answers. We're going to have a first quadrant answer, and we're going to have a fourth quadrant answer for that problem. So x is going to equal solution set 67.5, and we'll take the easy way out and say minus 67.5. And then we'll go back up to the original problem and see if that works. Okay, so we're going to go cosine 67.5 squared minus 3 times cosine 67.5 plus 1, and we should get something pretty close to 0, and we do. Alright, so our work checks. And now we're going to move on to number 18. And in number 18, we want to shift the way we think so that we think in radians. So now we're going to go 0 to 2 pi, and we're not going to talk about degrees anymore except where it might be helpful. Alright, so I've got a tangent of x plus 2 cosine of x is equal to secant x. And we want to solve for x. Well, let's see, I'd probably change it all to sines and cosines. So this is sine x over cosine x plus 2 cosine x is equal to 1 over cosine x. And then I'd multiply everything by cosine x, and I end up with sine x plus 2 cosine squared x is equal to 1. And then I'd say cosine squared x, let's see this, so this is sine x plus. I remember that 1 is equal to sine squared plus cosine squared. So 2 cosine squared is going to be 2 times 1 minus sine squared x, which is going to be 1. And then I'm going to say minus 2 sine squared x plus sine x. And the 1 comes over there, 2 minus 1 plus 1 is equal to 0. And then I ask myself, can I factor that? And clearly I could use the quadratic formula, but it looks like I can factor that. So I'm going to have 2 sine x plus 1 and minus sine x plus 1. And I got minus 2 sine squared. I get plus sine, and so that'd be okay. So now I need to find two cases. Case 1. Case 1. 2 sine x plus 1 is equal to 0. So the first case, sine x is equal to minus a half. Well, again, a half is a reference angle of 30 for sine x. Minus sign means I'm in the third or fourth quadrant. So in the fourth quadrant, my third quadrant would be 180 plus 30, 210. In the fourth quadrant, 360 minus 30, 330. And then I'd say, well, case 2 minus sine x plus 1 is equal to 0. Sine x is equal to minus 1 is equal to 1. And sine x is equal to 1 at 90 degrees. So in this case, I only have a first quadrant answer. X is going to be 90 degrees. So now I have a final answer. X is equal to 90 degrees, 210, and 330. And then I go back to the original problem. Bummer. Again, we're not thinking in degrees, so we have to get rid of all our degree ideas because we're doing this in radians. So we have to do the whole thing over again in radians. Okay, so again, that would be pi over 6 radians as a first quadrant answer. So in a reference angle, sine of 30 degrees is a half, so that'd be pi over 6 radians. So third quadrant thing would be pi plus 5 pi over 6, 7 pi over 6. In the fourth quadrant would be 2 pi minus pi over 6, 11 pi over 6. In sine of x is 1, that's going to happen at pi over 2. Okay, so we'll write our answers as pi over 2, 7 pi over 6, 11 pi over 6. Okay. Then we take our calculator and we change the mode. I'm going to change the mode to radians. Okay, so I'm in radians on my calculator. We're doing problem number 18. So I'm going to go the tangent of 7 pi divided by 6 plus 2 the cosine of 7 times pi divided by 6 minus 1 divided by the cosine of 7 times pi divided by 6. And I better get something very close to 0, and I do. I get something very close to 0. So I've checked the pi over 6 guy, the 7 pi over 6 guy, and we'll leave it to the rest of you to check the other ones. Okay, so that was problem number 18. Okay, we'll move down to problem number 26. Number 26, I have 2 sine x minus tangent x is equal to 0. Okay, I'm going to change the tangent to sine over cosine. I'm going to multiply everything by cosine. We're going to recognize this as the double angle and call that sine 2x minus sine x is equal to 0. Okay, so we have 2, and we're going to go from 0 to 2 pi. So sine x is going to go up, down, and back, and I'm going to get to 2 pi. And the sine of 2x is going to go up, down, back, up, down, back. So I'm looking at 1, 2, 3 answers. So when x is pi, the sine of pi is 0, the sine of 2 pi is of 0, So pi will work. So the answer there will be pi. Now the issue is, what is this guy right here? Okay, so one of them is going up and the other one is going down. And that looks like, if I had pi over 3 and 2 pi and 2 pi over 3. Well, that would be pi over 3 would be the sine of 60, and the sine of 60 is the same as the sine of 120. So that answer right there is going to be pi over 3. And then I would say, well, if I had to go to pi over 3 to get there, I'm going to have to go minus pi over 3 in order to get to that spot. So my other spot is going to be 2 pi minus pi over 3, which is going to be 5 pi over 3. Okay, so I'm going to say x is equal to solution set 0. 0? Well, 0 also works. Yeah, well, we're going to have to include 0. So there's another point right there. 0 pi over 3, 5 pi over 3, and pi. And we'd want to write those in alphabetical order, so we want the pi first. So we want pi, 5 pi over 3. Okay, so my calculator is in radians, and so we'll put in the 5 pi over 3 guy. And okay, so this is 26. We want 2 times the sine of 5 pi divided by 3 minus the tangent of 5 pi divided by 3 to be 0, and in fact it is 0. So we've checked that guy and we've checked both of these guys. So now it's a matter of, did we get that one right? And we probably did. Okay, now we're going to do number 34. Number 34. 1 plus the sine squared x over 2 is equal to cosine x. Okay, so our half angle formula for sine okay, so it's going to be 1 plus square root of 1 minus cosine x over 2 squared is equal to cosine x. 1 plus a half minus cosine x over 2 is equal to cosine x. I'm going to multiply everything by 2, and I'm going to have 2, I'm going to have a 3 is going to equal 3 cosine x. Multiply that times 2, put it on the other side, 3 cosine x. So cosine x is equal to 1. Well, cosine x is going to equal to 1 at one spot. It's going to be equal to 1 and 0. So x is going to equal to 0. And because I'm going between 0 less than or equal to x less than or equal to 2 pi. The 2 pi answer wouldn't be there. Okay, so now I'm going to try 0 in the original equation. The sine of 0 is equal to the cosine of 0. Yeah. So the sine of 0 is 0 and 1 is equal to 1, and that checks. Now, it would seem that I would have more answers than that, wouldn't it? Wouldn't it seem that way? It just seems that way. So, check our work. Figure out how we're going to check our work. So we have 1 is equal to cosine x minus sine squared x. Okay, so cosine x is going to go down, up, and back to 1. Cosine over 2x. Okay, so if I look at the period, I'm going to have 2 pi over 1/2. So I'm going to have a period of 4 pi. Okay, so sine is going to go up, down, up, down, because I'm going to have it squared. Okay, and we want a point where if I subtract them, I'm going to have 1. Okay, so if I subtract them, yeah, the only place, this is at 2 pi. So at 2 pi would, but again, I can't use that one because I'm not going there. So it looks like the only place I'm going to have an answer is going to be at 0, because all the other things are going to be smaller. So I'm subtracting this guy from somebody less than 1 all the way to there. So I'm only going to have one answer. It's going to be at 0. Okay, good enough. Okay, we're done with this section.